an incomplete diagram of an experimental setup to determine the thermal conductivity of a metal by the Searle's method is shown below. A. What are the purpose of inserting tube P and Q into the steam generator? You can identify there are two tubes in steam generator like this. This is the steam generator. Tube P is this one. It is not immersed in water. Tube Q is this one. It is immersed in water. We are using P tube to supply steam. We have to get steam through the tube P. Then we can write A purpose of P to supply steam. To supply steam to the cell separators. Then Q is maintaining to maintain ATM, atmospheric pressure. To maintain pressure. We know that temperature of steam is 100 Celsius degrees at atmospheric pressure. Therefore, we have to maintain atmospheric pressure to obtain steam at 100 degrees. Then we can make atmospheric pressure inside the steam generator by using Q tube. If we are using Q tube as a non-immersed tube like this, then steam will flow through the tube, flow out through the tube Q. Therefore, we have to immerse in water. It is only to maintain pressure. Then part B. Proper connection of steam and water supply to Searle's apparatus are necessary to obtain accurate result. According to, select the connection and give reasons. Problem number 1. Steam supply AOB. In Searle's apparatus, they have marked A is the this tube, B is this one. We have to insert steam from A. Because of if you are using B to insert steam will not pack in this container. Steam will flow out. Therefore, we can write the reason to pack steam in container. To pack steam in container. In part 2, water supply LOS. Now water supply is this one. There is a tube like this. We have to give a water supply to maintain steady condition of this metal rod. When giving water supply, it is compulsory to use this M input tube. Then we can write answer for part 2 M, because of we have to maintain a steady condition. It should have a steady heat flow. If we are using L to insert water, it will never given a steady condition. Then we can write reason to make a steady heat flow through the rod. Or we can write to ensure maximum heat absorption by the water. Now you can understand, when giving heat energy by the vapor in this container, this heat energy will flow through the rod. It should be give out by water flow of this tube. It makes a steady condition. Then part C, state 3 more measuring instruments needed to experiment and briefly state the specific measurement taken by each of them. We can write first one is stopwatch. Stopwatch. We are using stopwatch to determine time taken to collect water at a steady condition. Time taken, we have to collect water volume through this tube at a constant time when the rod is in steady condition. Therefore, we have to measure time taken to flow water through LM tube. And second instrument is vernier caliper. Because of we have to calculate cross-sectional area of the rod. To calculate cross-sectional area of the rod, we have to measure diameter of the rod. It is the second one. Third one, we can write meter ruler. We are using meter ruler to measure length of rod. We have to get the distance between two thermometers as the length of the rod. We have to consider only this length. You have to write only 3 instruments, but if you are written electronic balance, it also correct. We can use electronic balance to measure the mass of water collected in steady condition. Then part B, the separation between thermometers T1 and T2 is 8 centimeters. If the constant temperature readings of T1 and T2 73.8 and 59.2 respectively, calculate the temperature gradient. Temperature gradient is temperature difference theta 1 minus theta 2 divided by length. Then we can substitute values. Theta 1 minus theta 2, we have to subtract large temperature and small temperature. 73.8 minus 59.2 divided by length is 8 centimeters. I will use the SI unit. 18 to 10 to the power minus 2 meters. Then we can subtract 8 minus 2, 6. 13 minus 9, 4. 6 minus 5, 1. Divide by 8. We can bring 10 to the power minus 2 to the numerator as 10 to the power 2. 14 divided by 8, 1. 6 remaining, 66 divided by 8, 8, 1.8 into 10 to the power 2. So you can simplify further. 1.8 to 5 into 10 to the power 2. It means 182.5 unit Celsius per meter. Celsius per meter. Or you can use Kelvin per meter. Because of we know that when considering the difference of temperature, Celsius value is equal to the Kelvin value. Then part E, does this temperature gradient vary along the road? Briefly explain the answer. No. No. Because of we are getting feedings at steady condition. Steady condition. Part F. At thermal steady state, the difference in thermometer readings T3 and T4. T3 and T4 you can identify in the figure. 9.5 and the flow rate of water is 120 grams per minute. Calculate the rate of heat absorption by water. The specific heat capacity of water is given as 4200. Rate of heat absorption. We know that heat absorption is ms theta. We can divide by T to time the T time to get the rate of heat absorption. Mass over time, mass per unit time. It means mass flow rate. It is given as 120 grams per minute. 120 grams per minute. Then I will convert gram value to kilogram by multiplying 10 to the power minus 3. And we have to convert 1 minute to seconds. 1 minute is 120 seconds. Sorry, 60 seconds. Specific heat capacity 4200. Temperature difference is given as 9.5. Divide by 62. Then we can multiply. There are 2 zeros. 2 into 2 4. 2 into 4 8. Into 9.5 into 10 to the power minus 3. There are 2 zeros. We can multiply 84 by 95. 5 into 4 20. 2 remaining. 5 into 8 40 plus 2 42. 9 into 4 36. 3 remaining. 9 into 8 72. 72 plus 3 75. 0 8 9 7. We have to separate one decimal place. Then answer is what flow rate? Flow rate is given in what? Joules per second. No, there is a term 10 to the power minus 3 term. Therefore, we have to multiply by 10 to the power minus 3. 79.8 watt. Then part G. If the cross-sectional area of the rod is 12 square centimeters, calculate the thermal conductivity of the metal and state the answer with SI unit. We can write the equation for heat flow rate. Heat flow rate is H over T K A theta 1 minus theta 2 divided by L. This chi value is the K value is the chi OK value is the heat conductivity. You have to find it. We can get H over T value is this one 79.8. You have to find K value. Cross-sectional area 12 square centimeters. 12 into 10 to the power minus 4 square meters. This is the temperature gradient. It is found as 182.5. Then we can subject K value 79.8 divided by 12 into 10 to the power minus 4 into 182.5. Now we can divide it. Answer is 364.4 watt per meter per Kelvin. You can find the unit by using units of this equation. Part H. Is it possible to use the Searle's method to find the thermal conductivity of poor conductor? Briefly explain answer. No, we can't. Because of we can't get a proper temperature gradient when using poor conductor.